Hello everyone. You know, we haven't had a system with a 5¼ inch drive on the channel for a while, so I decided to check out these early 90s systems. That's right, we're going pre-Pentium. Let's tear into these. Starting with this fine example, this machine definitely has the look. Branded C&F Computers, which I've never heard of, probably just a little small-time computer manufacturer. See, we've got our keyboard lock there. All that does is disable the keyboard for extra security. And of course we have the turbo button. Okay, that doesn't work very well. We'll have to look at that. A fine assortment of LEDs. Got our 5¼ inch floppy drive there, and the vertically mounted 3½ inch floppy drive. There is something about the vertically mounted ones. It just gives it a certain aesthetic. And of course we have a real ka-chunk power switch. ATX and ACPI were not a thing yet, so this switch actually breaks mains voltage. And here's a look at the back. That printed label says ASI Pro, and it's actually just taped on here, so that may have been the MSP or something that was managing this system. And I already see signs of trouble. See that corrosion on the keyboard connector? More often than not, that's an indicator of a leaky battery. This system most certainly has a Varta battery. Those leak and corrode the motherboard, sometimes irreparably. So if you're evaluating a retro system to buy, this is definitely top of the list for things to check. And luckily, this machine has a VGA card. That's good because I don't have a way to capture a CGA or EGA, nor do I have a CGA or EGA monitor. Got our 9 and 25 pin serial ports there, got a game port, a parallel port, and a highly configurable modem, back in the day when you had to set the COM port by dip switches. Alright, let's get this thing open. And this case has 4 screws, 2 on each side. Looks like that's all it takes to get us in. Now it looks like we just slide back. There we go. Oh hey, we got a hard drive! Awesome! Looks like an old boy. And our enemy is confirmed. The most sinister name in all of retro computing. Varta. So let's get that motherboard pulled out of there and see what we're dealing with. Starting with the peripheral cards, of course. This here is the I/O card. Back in the day, IDE and floppy controllers and such things were not on board. This card also provides our serial ports. Let's get all that disconnected. Now let's get that breakout shield out of there first. And might as well get that IDE cable out of our way. There, that's better. And that's pretty standard fare for the time. Gold Star brand I/O controller. I'm very pleased to see no corrosion on that edge connector. Hopefully that means the battery damage isn't too bad. Yeah, nice shiny gold. It just needs some very light touching up. Got a year stamp of 1992. Now let's see what kind of video card we have. A Trident TVGA 9000A. That year is also marked 1992. And we've got our video RAM expansions. Oddly enough, this edge connector is not as clean, but not too scary altogether. And finally, the dial-up modem. 1991 logic code technology. Not quite sure the speed of this one. Probably 14.4. How many BBS services did this baby connect to? And with all that out of our way, we can see this system is powered by a 25 MHz AMD 386, and there's the BIOS up there in the upper left-hand corner. Okay, let's work on getting this power supply out of here. I'm probably going to have to pull the faceplate because that power switch is one of those soldered heat shrink dealies, so let's get to that point. And I'm telling you, it doesn't matter how strong you are, Molex connectors are always difficult. Let's get this floppy cable out of here too, why not? Okay, luckily the power pins aren't corroded. Now, how do I get that faceplate off? Looks like it's just screws. Okay, I'm pretty sure I got them all, but it's hanging up on the disk drive? That's odd. I guess I'm taking that out. Which on this case requires both 3½ inch drives to come out. That thing is awfully tight in there. This case has some crazy tight clearances. It's either that or something's a little bit out of whack. But now we can finally reach those screws. There we go. Now we can deface you. Just enough to get to that power switch. That thing's pretty loose in there anyway. And you are out. Since it's done hanging up on everything. Okay, I just can't help but stop and check. And it's not looking great. But let's continue pulling the motherboard. Let's get that front panel disconnected, which I probably should have done before removing the faceplate. And that hurts. You know it's bad when it takes the silk screening off. First things first, let's get that battery off of there. It even took the battery silk screening with it. But you know, I don't think it got the RAM. Those are some chonky clips. Let's see how this goes. There's no way to grab them. These aren't like the regular SIM-RAM clips. We're gonna have to use instruments. Those are easily the most nerve-wracking clips for SIM-RAM. And that's a Gold Star module. I'm seeing this CEM8122 sticker everywhere. Guessing that's from the manufacturer. Do not remove, or else. And this module is equally nerve-wracking. I'm definitely going to need an explanation for the rationale on these clips. And that's an identical stick. And identically forbidding. And it's really interesting how that corrosion caused these ceramic capacitors to split. Those batteries just wreak all kinds of havoc. Well, at least the underside of the board isn't too bad. It definitely got there though, but I don't see a whole lot of trace damage. Okay, next step is to neutralize the electrolyte to stop any further corrosion. And we do that using a dilute mix of white vinegar and distilled water. Just get it all over wherever the battery electrolyte made it. And then I like to work it in. And I'll just let it sit and do its thing for several minutes. And then I'll give the board a good wash. Okay, that motherboard's washed and dried. Now I can see there really aren't many traces on the outer layers. And that may not be a good thing, because it makes the middle layers really important, and those middle layers could also be corroded, and I have no way to tell, nor do I have a way to fix them. But let's just do what we can. First, let's depopulate some components, especially the keyboard and power connectors, all of these passive components, and these headers here. And I'm not sure if I'll have to remove the ISO slot. I'll make that decision once I get all this other stuff out of the way. Well, let's start desoldering. Let's get some flux on everything. And of course, my favorite thing in the world for cutting through this corrosion-hardened solder is the desoldering alloy. Make short work of that stuff. Mostly because it wicks through the upper solder joints and breaks that bond. Now I should be able to just give a few heat passes and pull that connector off. There we go. And same deal for the keyboard connector. Here's where this stuff really shines because these are really corroded. There we go. Though it definitely helped that both of those front lugs were corroded off. I need to get replacement AT keyboard connectors in stock. Okay, I got all that stuff out of the way. And yeah, there aren't many traces on the outer layers at all. Not feeling good about this one. Nevertheless, let's continue by getting rid of that corrosion and solder mask. The best tool for that is a rubber polishing bit on a Dremel. Some used desoldering braid is a great way to get the tinning process started. I'm going to try to avoid pulling that ISO slot. I think I can get around it. The traces under it don't look too bad. Okay, now I can start flowing some actual solder over these. And that's really just to shore up their current carrying capacity, because the corrosion thins out the copper, and that's just not good for anyone. Okay, now let's bridge all the broken parts. using various lengths of copper wire, especially this one. This one carries a lot of current. Get my pre-tinned wire strand in there. And let's just keel that over. And I'll take it to about here. Okay, that should do it. Now I just have to repeat that process for all the rest of them. Now, some of these wires I'm going to have to terminate through a via, so let's go ahead and make sure they're clean first. And for that I'm going to use one of these teeny tiny little drill bits. It's so small I can't even get focus on it. There we go. Okay, well, that's all of them. These couple adjacent ones I'm just going to bridge on the back side of the board. Same difference. I put a few components back on here just to help anchor the traces. And yes, I'm replacing all those electrolytics, as well as those cracked ceramics. Okay, let's get this cleaned up and repopulated. And since I have nothing to replace it with, I'm going to let this keyboard connector soak in CLR. Maybe that'll bring it back to a semi-usable state. Yep, already working its magic. I'd say that's looking better. Well, it's still a fluxy mess, but I got everything soldered back on. I'm really just anxious to test this thing, so I may come back and redo some of this later. You know what they say, any job worth doing is worth doing twice, especially if I find a new replacement AT keyboard connector. And here's where we landed on the back of the board. There wasn't really any trace damage back here, because there are barely any traces, so there wasn't really much to do. Okay, moving on to the drives. The 5 1/4 inch drive is made by Chinon, or Chinon. I have no idea how to actually pronounce that. Or maybe it's Chinon, model FR-506. And this thing has a few issues. The first of them being it's missing the cam that actuates the spindle here. And I searched everywhere for it. It is nowhere to be found. I initially thought that this piece of plastic just shifted forward a little, but that's actually just a stopper. It doesn't move around on the shaft. So let's just pop this cover off and see if I can at least free up this mechanism. Okay, this here must be the lockout mechanism thingamajig. So let's try sliding that back. Yeah, there we go. Okay, so at least it will be possible to test this drive. I'm just gonna have to sit here and hold it. Okay, well, let's go ahead and clean it up, because it is very dusty. Let's get those heads clean too. Alright, not too bad. And the 3 1/2 inch drive is a Mitsumi/Neutronics, model D359T2. This thing looks really interesting, particularly the logic board. Oh. Something rattling around in there. Noted. But look at the way they have this chip suspended here. That's not mounted on the PCB. There's a hole in the PCB, just slightly larger than the chip. I found that kind of funny. And the spindle is plenty spindly. And right off the bat I see what's rattling. No idea where that came from. Doesn't look like it's part of this drive. And we are pretty clean in here, just mildly dusty. Let's clean it up. Good, good. And let's refresh that grease. Now let's just do a quick test of the eject mechanism. Even though I'm 90% sure that loose part didn't come from this drive. Let's just make sure everything's in order. And yeah, works great. So there's no telling where that part came from. Although it is exactly the right diameter to be part of that broken cam mechanism. But how on earth it ended up in the 3 1/2 inch drive, that I could not tell you. Sure wish I could find the other half of it. And last but certainly not least, an old school Western Digital Caviar hard drive with a whopping 125 megabytes of capacity, manufactured May 30th, 1992. Oh man, I hope this thing works. Just imagine the time capsule software goodies that are on this. Yeah, I better level set and not hype myself up. Now let's check out that wirely power supply Nothing special about it at all. It's just your standard fare AT power supply. Seems decently constructed, made by Soltech, and I don't know what to make of that date code. It just doesn't make any sense. None of those could possibly be a year. Oh, but the side label has a date. November 29th, 1991. Now that makes sense. Let's see what this thing does. Okay, we're a little high on those voltages, but not too terribly high. It's jumping around a lot. Kind of unusual. But nevertheless, it did make it. Survived 5 minutes, despite that voltage being a little jumpy. No issues. And what do you know? I was just cleaning out the case, and I found the other half of that broken cam piece for the 5 1/4 inch drive. However, the chances of me getting this thing back together functionally are pretty slim. This type of plastic does not take kindly to adhesive. And I would also like to just stop and appreciate this case. Nearly every part of it is painted, and that paint really saved the day. Otherwise that battery would have badly corroded the case too. So now all I have is these standoffs to clean up. And luckily they're coming out of there. Let's just go ahead and polish these. There we go, nice and shiny. Okay, well, it's the moment of truth. I'm still not feeling good about it, but let's see. Ooh, hard drive sounds happy. Oh, it's posting. And that's not good. That sound means it thinks a key is stuck. Yeah, I figured we weren't done. Let's see, I didn't even watch the LEDs on the keyboard. That'll tell me if it's at least getting power. And it sure is. Okay, so that's not the problem, obviously. Let's see if pulling the keyboard connector shuts it up. And it does. Okay, yeah, I'm definitely going back into this motherboard. Okay, well, I've been poking, prodding, and not getting anywhere. Electrically, the trace repairs seem fine. They're all connected and nothing shorted. But, of course, I can't see what's going on in those middle layers. There is still one open question on this thing, and that has to do with the ceramic capacitors I replaced. They're all marked 47K, which I took to mean 47,000 picofarads, or 47 nanofarads. But the Google has been no help at all in confirming that. I even tried ChatGPT and Bard, and they were both equally confused, so I replaced them with 47 nanofarad capacitors, but I'm still not entirely sure if that's correct. And my meter gets no reading on these capacitors at all, which must be due to internal corrosion, because it reads the new 47 nanofarad capacitors just fine. I don't even get resistance readings out of these things. Why, oh why, are these things not standard? And it's already Wednesday, so this motherboard might have to go on the shelf for now. Okay, well, with that motherboard repair on the shelf, we still need to test these drives in that I/O controller. Luckily, my baby AT486 is always willing to help out. Okay, we're all connected. The Gold Star controller's in there. Let's see what they do. Alright, got a seek on both drives. And that hard drive just sounds as happy as can be. Well, let's see if we can boot from it. And of course that means configuring it in the BIOS. Let's see, I doubt that drive supports auto detection. But let's try. Oh, it does! Well, look at that. Okay, we accept these parameters. Let's get out of here. Save changes and exit. And yes, it did boot! To a very broken looking auto exec dot-bat. See what version of DOS this is. DOS 5. What do we have on here? Not much at all. But we do have Windows and AOL. See if we can get in the Windows. Yes, we can. There certainly isn't much on here, but I'll never pass up the chance to take a look at old Paintbrush. Oh, the memories. Let's see, there's got to be more on this thing, hidden away. No saving. Let's see, what's behind here? Solitaire and Minesweeper, of course. Hey, where's that AOL install? I may have to open that manually. Let's try running it from here. Whoa, what version of AOL is this? I'm not familiar with this one. The earliest AOL version I remember is 2.0. Let's see. Version 1.6. I sure wish we could sign on. Let's see what the email dialog looks like. If it'll even show. Huh, doesn't look too different than the later versions of AOL. What do we have in members? Can't do much without being signed on. So we can go to. Let's see if there's any cached network news. Nope. Well, that is cool. Definitely a new one for me. Let's get out of here. Other than that, this thing's pretty barren. Just got the usual DOS utilities. I guess that's the reason why we're only using about 17 megabytes on that hard drive. Okay, let's go back down to DOS. Let's run check disk on it. Just to see. And no bad sectors that it knows about. Okay, let's check out the 5 1/4 inch drive. And of course I'm gonna have to hold it the whole time. And I'm pretty sure that's A drive. Yep, sure is. And it's not happy. Yeah, I don't blame it. I wouldn't be happy either. Let's abort. See if we can format it. One-handed typing. Do it. It's not doing much. Yeah, can't even read track 0. But you know what? I need to recheck the BIOS. I didn't make sure it was set correctly. The floppy drive configuration, that is. Standard. A drive. Okay, yeah, it thinks it's a 3.5 inch drive. Let's fix that. Make sure B drive's set correctly. That's our 3.5 inch drive. Alright, let's get out of here. Save and exit. Let's try again. Okay, well, at least that's different. Let's try formatting again. Okay, there we go. However, I did get the format wrong. That's a double density disk. But you know what? That's usually a good workout for the heads. Yeah, work it. Feel the burn. And I see I missed some dust. I should have taken that PCB off. So this drive might work. Let's get a high density disk in there. My finger's gonna be sore after this. Let's see, there should already be something on that disk. Yeah, there we go. Got some stuff. So yeah, I'm pretty sure that drive works fine, which means we should be able to complete a full format on it. Do it. Yeah, it looks like we're good. No label. Yep, that drive works. So I guess it is worth fixing the latch mechanism. Let's see if I have such luck with a 3.5 inch drive. Yeah, it looks like it. Wow, 3 healthy drives. Save for a broken cam mechanism. But before I declare that hard drive healthy, let's do a surface scan on it, which means we're going to have to boot to DOS 622. And since I don't feel like holding that spindle down for an hour, we're going to boot to the 3.5 inch drive. Let's change that BIOS configuration back. Save and exit. And that system has some lovely sounding drives. Alright, let's do scan disk. Yeah, not well used at all. Oh, it's looking good. Yup, no bad sectors. You definitely can't beat that for the age of it. Even I have some bad sectors. Now, let's try to get some dates on this thing. I'm especially curious as to when AOL was installed. February 1997? That doesn't seem right, unless this thing was restored from backup. But command.com is from 1992, so that's most likely when this was installed. Let's actually look in the AOL folder. Okay, yeah, we got files from 1991 and 1992. That's far more believable. I wonder what happened in 1997, though. Who knows? Alright, since this drive proved itself, let's try to fix it. I need to figure out how to get that shaft out of there. That may require pulling the faceplate. So let's get rid of that lever. Should be able to just pull it off. There we go. And there are 2 screws under here. Should be able to just pull it off now. There we go. Flip it back over. Okay, I see how this works. We got to get that C-clip out of there, lift this entire mechanism up, and then we should be able to send the shaft out that way. First, let's disarm that spring. Let's get that C-clip out without sending it across the garage. Well, I figured that was a lofty goal. Let's see if I can find it. And you're not going to believe this, because I can barely believe it. I found it. One of these days my luck's going to run out with these things. Okay, let's get this bearing block thing at least loose. And we should be able to pull this thing right out of there. There we go. Okay, I've got that cam held together temporarily with super glue, because that's all super glue will ever be good for. Now my plan is to cut a groove around the circumference of it and reinforce that with epoxy. I also drilled a hole in it, why not? That way the epoxy can flow through and complete the connection to the other side. Well, it's not pretty, but it should be plenty strong. Let's clean off that old grease, because this needs to be as frictionless as possible. Now to take it for a test toast. If you get that reference, you win 1 internet. And that is fixed. One 5 1/4 inch drive saved. Well, I suppose this is the folly of trying to perform these repairs within a week's time. I only get but a few hours per system, and for motherboard repairs, that just isn't enough. But everything except the motherboard is great. Got 3 great drives, good video card and I/O controller, got to see AOL 1.6 for the first time. Yeah, this thing's still a win. And this case is a little bit tweaked right here, but overall it's still excellent, and it just has that ridiculously classic look. Let's move on to the next system. Next system is this AST Advantage Adventure 466. I guess they couldn't think of any more superlatives. This case is definitely worse for the wear. There's also something rattling around in there, and that may not be a good thing. And that 5 1/4 inch drive is so yellowed, I think that might be the actual color. I don't think I've ever seen anything so yellowed. And this faceplate's kinda being held on with hopes and dreams. Maybe we can do something about it. And that floppy eject button has been ejected, pushed in just a little bit too far. And here's the back of the machine. I see we have a sound card there. That looks interesting. We also have a NIC with a BNC connector, and everything else on board, including VGA. And here's a good look at that label. It doesn't give me a date though, unfortunately. And the underside of the machine has a little build sheet. And this thing has a 486 CPU, 486DX2. Let's hope all of that remains true. Now, as for getting in this thing, I only see 2 screws, one on each side at the back here. So let's start there, I guess. And I guess that screw wasn't supposed to come all the way out. The case has a little notch to slide past it. Oh well, it's out now. Okay, obviously this case is supposed to slide forward. But in this case, the system itself wants to slide backwards. I guess because we're missing those feet. The outer shell is actually the very bottom of it. That thing is tight. Well, that was fun. Okay, what the hell happened here? There's an entire chunk missing off of that riser. which also apparently contains the sound card. And here's the other piece. Well, that is severely disappointing. How on earth could something like that happen? I'm pretty sure there's no chance of fixing that board. Guarantee that's multi-layer. This has been quite a week. I've got something interesting here, though. This is a SimRAM expansion. Chameleon Technology SimVerter. This allows you to use 30-pin SIM modules in these 72-pin sockets, allowing you to reuse your older RAM. Whoa, this thing has a Texas Instruments 486. Check that thing out. For OEM use only. So I guess it came with the system. Thankfully, whatever monster did that to the riser didn't also damage it. Let's just pull it out and make sure. No, it looks good. That's so cool. I rarely ever get to see the TI 486s. It's always either AMD or Intel. Okay, let's try to get that riser out of there, since that is the most pressing issue. Let's get this modem out of the way. It's just your bog standard Cirrus Logic thing. Pretty basic. I wonder if this is original to the system. There's no AST indicators. I know that NIC definitely isn't. Linksys Ether 16 LAN card. ISA Ethernet is always welcome around here. Fortunately, it's not damaged. And no Varta demons here. This system uses a Dallas RTC that is very thoughtfully socketed. And that's good because I'm 99% sure we're going to have to pull it and do the battery hack. Those modules contain internal batteries, and as old as these systems are, it has long since perished. Okay, let's get this support bar out of here. I already pulled a screw that was running this way, so we should be able to just pry up on this. There we go. And snatch whatever's left of that riser out of there. Oh, that pisses me off. This board is 100% pure unobtainium, and they just tore through it. And there's absolutely no fixing it because this is a multi-layer board, which means there's traces sandwiched in between the layers. Otherwise, I would definitely try. So I guess this is going into the spare parts bin. At least that ESS audio drive chip survived. That may come in handy if I ever need a replacement. And I guess the real target for that massacre was the hard drive, because it has been removed. Let's clear all the rest of this stuff out of here. It's the audio cable that we won't get to use. And what is that? Oh, that's a 72-pin SIM module. Hey, I'll take it. Okay, well, at least everything else looks good. We should still be able to test this motherboard. I'm pretty sure it will run without the riser, but I make no promises though. It still may not. Now let's get those drives out of there. Looks like there's just 2 screws left in the front. And I've got those out, so this whole thing should pull out. And get hung up on the power supply. There we go. And the 3.5-inch drive is a Sony MPF 520. Let's get it apart and see if I can fix that button. That thing is very broken. Let's just get that out of there and get that faceplate off. Yeah, something caused this to lift up. Let's pop that button out. Let's see if I can get this thing back in the sorts. Alright, it took some fiddling, but I think I got it. Let's see. Yep. And it did just pop out there, but it should be good once the lid's back on. Let's clean it up. It is at least clean. Let's see how it does now. Working great. And the 5 1/4 inch drive is at least mechanically undamaged. It's made by Mitsumi, or Neutronics, model D509V2, and apparently the original color is gray, though that is the yellowest gray I ever did see. Let's get that shield off. And we're surprisingly clean in here too. And that latch mechanism at least works. Let's clean this thing up. And that CD-ROM drive is made by Torisan? I'm guessing that's how you pronounce that. It's a 4-speed drive, manufactured May 1996, so very likely original to the system. Now onto the power supply. It's made by Hi-Pro, looks like an AST original part, and I generally have good luck with Hi-Pros. It seems decently constructed enough, so let's give it a test. Power on. Alright, doing just fine. These sacrificial hard drives are going to outlive us all. Alright, 5 drama-free minutes later, we're all good. And as for those faceplate clips, they're not as broken as I thought they were. It's kind of weird. The clips are actually in the middle here, and then they have these fingers to hold pressure on it. At least I think that's how it's supposed to work. It could just be severely broken, and this is supposed to hook around the metal. But as of right now, I was able to sort it out, and the faceplate does at least stay on now. And I do find it kind of funny that they have a metal liner inside a metal case. This whole thing is metal. They wanted to make sure this thing was shielded. Okay, will it boot without the riser? It's time to find out. I also haven't hackulated the RTC yet, so we'll see if it complains about that. Let's get a boot disk in there and see what it does. And it's posting. And as expected, system battery is dead. Replace and run setup. But at least that's a good sign, so we can run without the riser. Let's go into setup. That's odd. Keyboard's definitely connected, but not working at all. Wonder if I just need to deox that keyboard port. Yeah, that rust certainly isn't a good sign. Let's see if that helps at all. Nope. Okay, let's go ahead and hackulate that RTC, because that can cause all kinds of issues. And I just love when they're socketed. And I'll just give a quick summary of the procedure here. We gotta drill into this thing in order to access the battery terminals. Specifically, we need to drill above these 2 missing pins. Once that's done, we just solder on some wires for an external battery connection, and we'll have a working RTC again. So let's drill. You don't have to go far, just until you hit the metal of the terminal. And with those exposed, we can just solder onto them. A little flux always helps. And I just glued a regular CR2032 battery holder to the top, and that works just fine. Okay, let's try this again. That's better. But does the keyboard work now? Yes, it does. However, I don't think that floppy drive survived. Yeah, definitely not. Well, let's just make sure it's configured correctly. Let's get in the setup. Warning, the CMOS checksum is invalid. We know this. Okay, let's go to System Setup. Drive A is correct, but Drive B is not. Let's fix that. That shouldn't have stopped it from booting. Alright, let's get out of here. What is under security and antivirus? I thought this thing might have had some on-chip antivirus for a second. Now let's get out of here. Alright, let's save this out. See if it boots now. Changes have been saved. But it didn't exit. Guess you have to push F10 for that. But I just saved it. Yes, save before exiting. Yeah, that floppy drive ain't doing it. We're gonna have to get a surrogate. Alright, the surrogate is in. Let's switch the disk over. Yeah, now we're booting. And there's our CD-ROM drive. Though that is a strange place for the cursor to land. What's up with that? Okay. Okay, well, let's see if that 5 1/4 inch drive works. Doesn't sound great in there. I think that's a no. Are both floppy drives really dead in this thing? Let's hit abort. Okay, well then fail. Go to A drive. That is so weird what's going on with the cursor. Well, let's see if it'll format. Okay, that cursor is possessed. I've never seen such strangeness in DOS. And yeah, not working. That's the same disk I used in the last system. Let's just try another one, just to be sure. Format another. And yep, hates it. 0 for 2 on drives in this system. Surely the CD drive won't let us down. That was one slow, deliberate mechanical opening. It's just a little bit dusty in there. Let's see what it's got. Sounds like it spun up. Alright, at least that drive works. You just can't beat an old 4-speed, man. Alright, let's see what that TI 486 is made of. Well, it seems to be in line, but we are running at 22 megahertz, which means turbo mode probably isn't on. I'm not sure how to toggle turbo mode. I know it's got to be a keyboard shortcut because there's no button. Okay, let's test the CD drive. Okay, it just rebooted. That's weird. Let's see, toggling turbo mode is usually Control-Alt+. Okay, that sounded affirming. And to toggle it off, it's Control-Alt- usually. Okay, that seems legit. Let's do Control-Alt+ again. Let's see what speed this says the clock speed is now. No, that didn't change. But will it crash again? Let's try that. CD test one more time. Yeah, sure does. Let's get into setup. Maybe I can toggle turbo in there. Okay, well, not in there. Was it in system setup? Nope. Green PC features? Certainly not. Oh well. Guess I'll have to scour the internet and figure out what that keyboard shortcut is, if there even is one. I'm not all that familiar with AST systems. I am still so mad about that riser. That just about cost me my temper. And I guess it's no surprise that neither of those floppy drives work. This thing was pretty beat up. It definitely was not loved. And whatever plastic that CD-ROM drive is made out of, they need to use that on everything. This thing is just so ridiculously yellowed. I even noticed that behind the latch, it's not yellowed. So this thing was exposed to something nasty. But if I found a riser and did some retro bright, this thing would be fine. After replacing the disk drives, of course. Rechargeable batteries attached to circuit boards. Worst idea ever. And what kind of a person smashes through a riser? Honestly, it's been a rough week. But I want to give a huge thanks to all the fine people on Patreon. And if you're new here and you like this kind of thing, I got a lot more videos like it, and a lot more coming. And most of the time the systems aren't a disaster inside. But that's all for this video. Thanks for watching.